All right, so I think this is recording. Let's take a look at these three problems. And each problem, they're asking us to find the function composition, to find f composed with g, and then find g composed with f. So let's jump in and take a look at number 7. If we find f composed with g, we're having the function g be the input of f. G is 3x squared plus 1. F will always take the input no matter what it is and simply double it. So f composed with g is this new function, 6x squared plus 2. It always takes whatever we give f and simply doubles it. We can build a new function, g composed with f. This time f is the input for g. F is 2x, and g always creates an addition problem where the first term is 3 times the input squared, and then we add 1. So this time the input is 2x. So if for our final answer, 3 times 2x squared, well, 2x squared, 2x quantity squared is 4x squared, and 3 times that is 12x squared, and then don't forget the plus 1. So there's the two answers for number 7. Hopefully I didn't make any silly kind of error. Let's take a look at number 8. We'll use f and g to build this new function, f composed with g, where g is the input of f. G is x squared minus 1. And what f does to the input, f always creates an addition problem, 5 times the first term plus 2. So this f composed with g of g is 5x squared minus 5 plus 2. And the negative 5 plus 2 gives us minus 3 there. There's the answer I get for f composed with g. For g composed with f, f is now the input of g, and f is 5x plus 2. And g, well, g always creates a subtraction problem where the first term is the input squared and then it subtracts 1. Remember that exponents do not distribute, that this is 5x plus 2 times 5x plus 2, 25x squared plus 20x plus 4. If you have to do that in the form of a table, then do that off to the side somewhere. I get for my final answer 25x squared plus 20x plus 3. If I haven't done something silly and stuff. All right, so let's see. We still have one more to go. So in number 9, if we use f and g to build a new function, f composed with g, where g is the input of f, g is 4x plus 1. F will always take the input no matter what it is and square it and subtract 2. Four x plus 1 quantity squared, 16x squared plus 8x plus 1. Our final answer is this new function, 16x squared plus 8x minus 1, unless I've done some type of silly type of error. So if we use these two functions to create a new function, g composed with f, or this time f is the input, so what does g always do to the input? Well, g always creates an addition problem, 4 times the input plus 1, where the input is x squared minus 2. So this g composed with f, if we distribute the 4, 4x squared minus 8 plus 1, I get 4x squared minus 7. So I hope that helps, and I'll talk to you later. Ask any questions if needed. Bye.